Right, friends. So, welcome to this live stream. And today we will start Akulmach live by talking about the subjects on science. And today we want to discuss about something very interesting, something which is intriguing all of us. And it's about the elements. We know that there are periodic table. Periodic table is something that we study in our schools. We all know that, and we know that these colorful band describes the properties of similar elements. And painstakingly scientists have been able to put them all together, and that is why we call them periodic table. Now the whole point is that there are up to uranium, there are elements which are heavy elements. We know that these are all radioactive elements, and up to uranium is also very big in size, and we do not find anything which is beyond that uranium. In fact, there are other elements up to 118, because uranium is 92, up to 118. But those elements are temporary, they are not stable, and they disintegrate. Most of these elements have not been even named. Let me show you the periodic table again. So the thing that you see here in gray in the last, from 113 to 118, these are the elements which are not even named. And considering this, the heavier you go, it's the nature as we understand today that the elements are unstable. However, it has been hypothesized that there could be a possibility that there could be heavier elements also existing somewhere in the space, but so far we have not been able to find the heavier element, heavier than what we see in the periodic table, because anything beyond that is not stable. They disintegrate very quickly. They have a very short half-life, and by the way, half-life is something we call when the material completely decay, half of it within a limited time. So in a very short period of time, these heavy elements decay, and we are not able to find the existence, proof of existence of these heavy elements until now. So what is going on in this space? Before we discuss about the heavier elements, let's understand how the elements are produced in the first place. So essentially, when the universe was born, there was only hydrogen. However, quickly that hydrogen accumulated in the stars. They formed the first stars, the first generation stars, and then they burned very quickly, and because of the pressure in the center of the stars, the hydrogen starts making different element. That means if you look at the hydrogen, essentially hydrogen is nothing but a proton and an electron. So very simple, very basic, and there is a possibility, because of this extreme pressure, the hydrogen atoms will start fusing together to form heavier elements, and therefore these heavy elements then further fuse together to create more and more elements. So essentially the stars are the element producing factories. These are the factories where the heavier elements are fused depending on the size of the star. However, there is a limit to this, as we understand today, that the stars cannot generate whatever they do, whatever size they have, but they cannot generate bigger elements than iron, which is on the periodic table it is 60. That means 60 neutrons and 60 protons. The atomic number of 120. The weight of the iron atom is about 120. So it is difficult, because as I have told you in the beginning, that if you combine two iron atoms, you get atomic number of beyond 118 on the periodic table, which is not stable as far as our understanding goes. So after the iron is formed in the core of the star, the element creation factory shuts down, and iron actually start consuming the energy of the star, because the further nuclear reaction cannot happen, and then the star explodes, basically dies in whatever form. Either it forms a black hole, or it forms a neutron star, or a white dwarf, depending on the size of the star. So as I'm showing here, that if the size is average star, then it will become red giant, and then it ends into a white dwarf. If it is a larger star, which are massive stars, then it will actually explode into a supernova when the iron is formed at the core. And then there are two possibilities. One is that it can form a neutron star, or it can straight away collapse into a black hole. So where is the possibility of finding elements like gold, lead, silver, uranium? Because when the stars are not able to form these elements, heavier than iron, then where these heavier elements are formed? And we also know that in the beginning of the universe there was only hydrogen. That means these heavier elements, heavier than iron, has either got created in some process, and or probably come from somewhere else. So this has been a mystery, and subsequently now we find that the heavier elements are formed in a fraction of a second during the large supernova, and also in bigger celestial body collisions like neutron stars. So when two neutron stars collide, there is a possibility of a new type of atomic reaction taking place, because the conditions are so wild, so fierce, that the heavier elements are formed, heavier than iron, things like gold, etc. And those processes are known as R process. And I will explain what is an R process. It is slightly different than a nuclear fusion reaction. It is a different kind of a nuclear reaction. So that is why the heavier elements, heavier than iron, are so rare, and that is why we also call them rare earth element, because they are also found, they are rare on earth also, and they are very expensive. Because if you see, the gold is quite expensive, platinum is expensive, titanium is expensive, simply because there's not too much of it in the universe, and therefore it is not produced in a large quantity, unlike anything below iron and up to hydrogen. They are abundant, all these smaller elements are abundant everywhere. So in order to find these heavier elements, we have to look at other processes like collision of neutron stars. And as you know that neutron stars are quite heavy. They are only 20 miles across, but they may have a weight of 2.5 times the mass of sun. So there's a lot of mass compacted in a very small ball, and when two neutron stars collide, there is a lot of material to create all kinds of permutation combination at the nuclear level. And that is when these two stars, neutron stars, collide, the heavier elements are created. So let's move on. And when we started understanding the neutron star collisions, we actually started detecting the creation of heavier elements like gold, lead, silver, titanium, uranium, etc. And by the way, I must clarify here that plutonium is an element which is created in the nuclear reactor, which is a bomb, nuclear bomb grade substance. So plutonium is very radioactive. It degenerates. That is why it is used in the atom bombs. So let's move on. Now we have established that the neutron stars are also capable of producing new elements, heavier elements, because the lighter elements are produced in the cores of the star. So this neutron star uses a new type of or different type of fusion, which basically is described by scientists as R process. By the way, even today we do not understand a great deal about R process as the research is on. However, we know some bit of it based on our observation. And what it takes is basically some sort of process where the neutrons are rapidly absorbed by the iron nuclei. So when the RA nuclei absorbs the extra neutrons which are available, especially in the case of collision of neutron star, because neutron star, as the name suggests, is made of neutrons only. And then if there are iron atoms which are found on the surface, small bit of iron atoms on the surface of the neutron star, only in the form of nuclei, during the explosion the conditions are so fierce and so violent. When the neutron star collides, you can actually see these collisions so bright that they outshine the entire galaxy. So when the temperatures are so high, pressures are extreme, and there are little bit of iron atoms which are found on the surface of the neutron star, very few, because rest of the material is neutrons. These iron nuclei actually absorbs the extra nucleon because of the neutrons, because of the extreme conditions, extreme temperature, extreme pressure. And then something miraculous happens in the R process, that the neutron basically becomes a proton releasing the electron. And this is called beta decay, because if the neutrons are absorbed, then obviously it is not stable, and then immediately it decays by emitting a electron. And once the electron is emitted from this extra neutrons which have been absorbed by the iron nuclei, then obviously it becomes a heavier element. So this is a very rare kind of fusion reaction which could happen only in the hearts of the neutron stars. However, now the question is that recently scientists also hypothesized that there could be more heavier elements, bigger elements than even uranium that could exist, because as per the study, the scientist says that even though bigger elements are not stable, they decay quickly. However, if the atomic periodic table number is around 260 or above, then it can form even heavier elements and stable elements. So far we have not been able to detect these heavy elements anywhere in our universe. Nevertheless, scientifically it is shown that this is possible. The heavier than 260 number on the periodic table can be stable, or at least can be fairly stable. We will have a decay, and therefore the search is on. And then as part of the search, scientists found that there are certain elements found floating in the stars which cannot explain the existence of silver, etc., forming within the star. So while doing that study, they hypothesized that these heavier elements could have been formed in the early stars. Well, now let's understand what are these early stars. When the universe was formed, there was only hydrogen, and quickly hydrogen accumulated and formed the early star, first generation stars. These stars were massive, they were very huge. 300 minimum, the smallest star could have been 300 times the mass of sun. Very, very big stars. They burn very quickly, they shine brightly, and they exploded in a massive explosion. So since we do not have any evidence, it is a hypothesis, because we are also searching for the existence or the creation of supermassive black holes, and it has been linked to these first generation stars. And now scientists are saying that these first generation stars could have been factories for making even heavier elements than iron, and in their cores, because they had so much pressure, so much energy, so much material, the iron could not absorb or stop the compression of the large star. So there could be possibility that this R process could be running in the cores of star itself, and the neutrons can be absorbed by the iron core, and then it can form something which is very, very heavy and stable. Why scientists are saying that? Recently they've basically were studying about 40 stars in our own galaxy, and they found that there was a presence of or rather abundance of silver and other heavier elements, which could not be possible for the star to create, because as I told you, the star's element creation factory stops when the iron is formed. So there was no way a star could form heavier element like silver, etc. And therefore the scientists are suggesting that these large stars could have created the heavier elements, which quickly decayed into silver, etc., which later was absorbed by the large stars. So the whole point is that even though we have the guiding principle of periodic table, and we know that the heavier elements heavier than uranium are very unstable, very radioactive. However, if your periodic number is 260, that means your elements are much heavier, much bigger, then it could create a proposition of building much stable heavy elements. Now, what is the characteristic of those elements? Like, for example, we know characteristic of uranium, we know characteristic of gold, silver, even iron, and every elements which are present in our periodic table. Well, the answer is simply we do not know, because first of all we have to basically detect these heavy elements in our universe somewhere, and if we are able to detect them heavier than uranium, stable elements, then we will be able to basically do more research and identify the characteristics of these heavy elements. But the point is that the heavy elements would have been created by the first generation stars, and because of that we find little bit extra abundant quantity of elements like silver and lead, etc., within our third generation star. And today the stars are third generation. That means the first generation stars created heavier elements, then the second generation stars also came and gone, and now we are in the third generation star systems all across the universe. So friends, this is something which I wanted to share in this science show today.